In this video, we're going to go over the parent function for secant. Okay, so we know it says using your unit circle, the graph of y equals cos of x, which is here in black. This is our parent function, two full periods of cosine. And your knowledge that secant of x is equal to 1 over cos. 1 over cos. Okay, graph y equals secant of x in the interval negative 2 pi, less than or equal to x, less than or equal to 2 pi. Then identify the domain, range, asymptotes, period, and if the function is even or odd. Okay, so I'm just going to do a quick sketch again of unit circle values for cosine. We know 1, 0, 0, 1, negative 1, 0, 0, negative 1. And remember, cosine on the unit circle are your x values. Okay, and this is at 0 radians, pi over 2, pi radians, 3 pi over 2 radians, and then technically also 0 and 2 pi. Okay, so cosine is your x values. Okay, your cosine values. So cosine. So if we were to do secant, okay, let's kind of make a little table values. Let's do x secant of x. So if we subbed in 0, secant of 0 would be the same as the reciprocal of cos of 0. Well, it would be 1 over 1, which is still 1. So we're going to plot at 0, our value is going to be 1. If we plug in pi over 2, we know that cosine of pi over 2 is 0, so it'd be 1 over 0, so it's undefined there. So that means that we're actually going to have an asymptote at pi over 2. And we'll go to pi, 1 over negative 1, so it's negative 1. 3 pi over 2, we're going to be at 1 over 0 again, which is undef. We have a vertical asymptote there. And then at 2 pi, it's going to be 1 over 1, so it's 1. Okay, so this is technically from 0 to 2 pi is one period of secant. So similar to like what we did with sine and cosecant, right? One value that we can plug in that's pretty simple to take the reciprocal of is if we did cos of pi over 6. So it'll be 1 over a half, which is 2. So pi over 6, if you recall, is about a half a unit. So this is about 1.5. So a half a unit is about a third of the way there, right? So it's about here for our so it should be about somewhere around here. This is our value cosine of pi over 6. So instead of it being at a half, it's going to be at 2 for secant. And we see that it's going to kind of look like a parabola here. And same thing at 5 pi over, sorry, this should be pi over 3. That's why. Sorry, guys, it should be, the value should be pi over 3. It's going to be 1 over 1 over a half, which is going to be 2. So pi over 3 is a little bit more than 1. So it should be closer to about here, and that makes sense. Okay, and then I'm just gonna redraw this a little bit here. So it's about 2/3 of the way there, and we're gonna be at 2 instead of at a half. Okay. And we'll graph that there. We can do the same thing at 2 pi over 3, so it's about 2 units, right? So it's about here we would be at a half. And instead of it being at a half, we're going to be at -2. And in quadrant 3, we would be 4 pi over 3, -2. Okay. And we'll have kind of the same thing here in quadrant 4, right? So this is technically one period of secant, okay, from 0 to 2 pi. And it's similar to kind of like with cosecant, where we would have our asymptotes, and then basically whatever sign looks like for cosecant, we would just flip the direction of the parabola. And it's the same thing here between 0 to pi over 2. It's a downward facing parabola, the right half, so this becomes upward facing, and vice versa. This is upward facing between pi over 2 to 3 pi over 2, so it becomes downward facing, so on and so forth. So we're going to just kind of map out the other parts here. Oops. Here's your asymptotes. I'm just going to erase really quick. Okay, so we have our asymptotes there. And we'll do the same thing. The max of each region becomes the minimum of the other. So at -pi, because this is the minimum, it'll become the maximum for secant. And then -2 pi here. So there you go. That's 2 full periods. Okay. Our domain is all real numbers except x can't equal pi over 2 plus n pi, right? So we saw that our first asymptote was at pi over 2 radians, and then if you add another pi or you subtracted pi from it, you're going to get the next radian for the parent function of secant. Similarly to cosecant, the range, our default range again is -infinity to infinity, but because it's not continuous, we're going to have a pit stop at -infinity to -1, close bracket because it can equal -1, union, and then it jumps from -1 to 1. So then we'll close bracket here, 1 to infinity, like that. Our asymptotes occur where the function is undefined. Vertical asymptotes at x equals pi over 2 plus n pi. And then our function is technically even, and we can see that pretty much. This is probably the portion of the graph where we could see it most clearly, right? And in between -pi over 2 to pi over 2, there is even symmetry. Oops. A little bit messy there with the handwriting. Symmetry. About the y-axis. And the way we could tell here, okay, example at pi over 3, we have 2, and if we were to switch the signs, -pi over 3, we would still be at 2. Okay, let me actually put that in, let's do that in green. those points there in green for that graph. Okay, so that is our parent function for secant. Okay, based off of you can graph sine. We can graph cosine first, and then essentially figure out where the asymptotes are and reverse the direction of the parabolas in between.